Hey, today I thought I'd work on an integral from MIT Integration Bee 2011. This was problem 22. We have the integral of sine 101x times sine to the 99th x dx. Okay, I gotta tell you, this one was pretty tricky, especially at first looking at it. The fact that we have a different angle on the sines and we get this large power, there's a lot of problems here. So I thought what we could try maybe was using some trig identities, particularly the angle sum formula for sine. Okay, so we have here our angle sum formula for sine, and what I want to do is use it on, we're just going to focus on this piece, this sine 101x, and try to break up this angle in a way that's going to help us. And what I think is going to be the best way is if I write this, using this formula, if I write this as sine 100x plus x. So you notice I could have applied this any number of ways, right? I could have chose 95x plus 6x. The nice thing about this is just having an x here. The way this sets up, you can see that we're going to have some terms. They're going to have just an x, which matches this here. If we were to do something like, if we were to do 95x plus 6x, we've got nothing that's going to help us with this term over here. So now let's just apply this and see what it looks like. So again, this will be our a and this will be our b. So using this formula, we're going to have sine 100x cos x plus sine x cos 100x. And then what I want to do is we'll take this and put this back into our integral. What I'm going to do is when I multiply this back in, we'll distribute the sine to the 99th x, and we'll end up with two integrals. So let's see how this is going to look. Okay, now after the rewrite, you'll notice we've got our two integrals. One thing to note, you notice we have sine to the 100x here. This is because we multiplied sine x times sine to the 99x to get sine 100x. So from here, I think what I'd like to do is use integration by parts. I'm going to kind of focus, this one looks a little simpler, so we'll focus on this one for now, and we'll just try integration by parts on this. And I'm going to use the DI method or tabular integration on this. So we'll have one side to differentiate, one side to integrate. I think the choice is pretty clear. I think sine to the 100x is pretty hard to integrate. So what we'll do is we'll differentiate sine to the 100x, and that's actually perfectly fine to differentiate, and we'll integrate cosine 100x. Then we'll take a derivative here. Derivative of this is going to be 100 sine 99x, but then we have the chain rule, and we're going to have a cosine x come out. Then here, the integral of cosine 100x is going to be sine 100x, but of course we're going to have to pull a 100 out in the denominator here. Okay, from here, let's summarize what we have, but I'm going to do a little shorthand. I don't really feel like erasing the board right now, so I'm going to call this integral here, our first integral that we haven't dealt with, we're going to call this I. And then coming back here, so our diagonal is going to be part of the solution, so we're going to have sine to the 100th x sine 100x over 100. And then here, so this piece here is an integral. Notice when we set this up, the 100 and 100 is going to cancel. And we're going to have sine 99x cos x sine 100x, but that's exactly the same as what we have here. So where this thing is actually, when this all cancels out, this is actually going to be a minus I, and that's perfect because this is going to cancel with this, and we're just left with our solution. So we're going to have sine to the 100th x sine 100x, and that's it. Pretty crazy problem is we did reverse product rule, but you couldn't tell really from the initial problem that was there. But usually when we're looking at reverse product rule, there's going to be an addition. We didn't have that initially. We created it through this identity here. So anyway, thought it was a really interesting problem. We'll stop it there. Thanks everyone for watching. Have a great day.